Thanks, Steph, for coming today and giving me the opportunity to talk to you about Velociraptor, which is our new open source endpoint visibility tool. And I'm actually really excited about it, because I get to call myself a digital paleontologist. So yeah, I guess that's kind of cool. Yeah, so what is Velociraptor? You might have heard about it. I mean, we've sort of been, it's been around for a little while, and you might have heard about us. So here's me, and Nick Klein is my business partner, and we are the people behind Velociraptor. So what is the need? Why do we need Velociraptor? So the thing about Velociraptor is that it provides deep visibility of your endpoint, and you might already have an EDR tool or a virus scanner on your endpoint, and that gives you a lot of visibility. And as things become more and more encrypted on the network, we need to increase our visibility of the endpoint. We could do threat hunting. You need to be able to look for something that is unique. Something that's different, and it needs to be very flexible. At the same time, you don't really want to be pushing new updates to endpoints because there's process management, there's deployment management, and so this is kind of it's kind of a trade-off. On one hand, you want to be really flexible to be able to essentially respond really quickly to new threats, to collect new kinds of evidence really quickly. But on the other hand, you can't really deploy new software to the endpoint, so you can't just, there are other open source endpoint tools, and you might be able to write a patch or whatever to the endpoint tool, but then you have to push it out. So our goal is actually to develop a tool that is really flexible, really powerful, and doesn't require a lot of updates to be able to respond to rapidly changing threats. So let me just give you a quick technical overview, and it's kind of a very very typical architecture. On the left side, we see all the endpoints that we support. Windows, Linux, macOS, and we deploy Velociraptor server that can be on-premise or in the cloud, whatever, with a GUI front end. It's got some data storage and file store, and then we have encrypted communications to the endpoint, so we can essentially query the endpoints for whatever we want, instantly. So there is a GUI, and users, the investigators or analysts, can use the GUI to essentially ask various questions of the endpoints and try to collect artifacts about what's happening on the endpoints and that sort of thing. So that's basically the architecture. It's a fairly typical architecture. The only difference from maybe other architectures like GRR is that we don't really do any polling. There is a persistent TCP connection that we can use to stream data constantly, and so that means that if you've ever used GRR and you had to task a client and you had to wait for the next poll, and it's like 10 minutes, and it's kind of annoying. But so we don't have that. We just have so it's immediate, right? So very quick. Okay, so the other thing that we thought of, we wanted to make Velociraptor really easy to use and easy to deploy. So it's just a single binary. It doesn't really need any DLLs or any dependencies, so you can just push it out and run it statically compiled without any libraries. It's the same binary for clients and servers, so just one binary, and it just runs being a server or a client depending on command line options. We don't really use a database at this point, so that makes it really easy because we just collect files. Velociraptor is really just a collector, so it doesn't necessarily want to do any of the analysis like the Splunk or the ELK stack or ELK stack that you want to do. It just collects those files, and if you want to then go ahead and put that into another stack, that's totally fine. And so that means that we basically just kind of produce files like CSV files, and we just can grab files. So we don't really need a database. So we are all just file-based right now. And you can customize the configuration and so forth. But what is really the main difference between Velociraptor and other tools is the implementation of a query language. Now, it's not the first tool that uses a query language, and you might have heard of OS Query, which was the first tool that really just kind of hit on this idea that we could write a query and then query the endpoint for its state using a query language. And OS Query uses SQL. But Velociraptor uses VQL, which is an extension. It's an extension to SQL that allows it to do much more powerful things. And so in reality, all Velociraptor is just a VQL execution engine. So that's how you talk to the endpoint, is you just send queries. And then the endpoint runs the queries, and then you basically collect them, right? So a query is just something that produces a table of results with rows and columns. And so essentially, we just send the queries to the endpoint, but nobody really wants to write queries because it's kind of complicated and long and tedious. So we have this concept of artifacts, which I'll go into later, which is just a way of kind of giving the query a name and taking parameters and sort of writing it in a YAML file so it can be reused, so that query can be reused. And so we call that artifacts. So artifacts are typically collecting a specific type of thing that we are after. Okay. What we actually really want to do with artifacts is to kind of encapsulate the knowledge that a DFIR person would have about what they are looking for and what they're expecting to find inside a YAML file, so that the user doesn't have to know all the details about, like, where should I look for these files, where is the internet history files stored, where are the event logs stored, that kind of thing. That is all encapsulated inside the artifact file. The user just says, I want to just go and grab all the internet history files, and there we go. So when you write an artifact, the artifact is really about answering a question. So it's kind of a high-level thing, and the actual mechanics of how to answer this question is the more lower level. So we have different levels of artifacts, very high level, and then we might just say what programs were executed. In order to answer that question, we might need to look at a number of different evidence of execution places, and that's where the forensic kind of knowledge comes in. And a forensic expert might say, well, you might look at shim cache, you might look at prefetch, you might look at executables on disk, modification times, timelining, that kind of thing. But each of those will be an artifact. So if I then said, okay, what's a shim cache? Oh, well, there's a shim cache artifact. How do I find it? And then that artifact goes and finds it for you. And so that mechanics of how that works is also encapsulated in an artifact. But on the bottom level, everything is really just running VQL queries. At the end, it's just all queries, and it all goes to the endpoint. So you can implement a new artifact yourself without having to redeploy a new client just by itself. So here's an example of what an artifact looks like, and I don't really expect you to read it, but you can see these big blocks. And so the top level, we have a name, and an artifact just has a name and a description, so we can search on it in the GUI. It's a YAML sort of file, and then it takes maybe a bunch of parameters. The parameters could be, anything that the artifact wants to take. Like in this case, this particular artifact searches for parents execution. So like, if this process is called, SVC host, then it has to have a parent that's called, so it can't have a parent that's called cmd.exe, right? It has to have a parent that's called system and so on. So in this here is the parameter, which is just a lookup list of, the parent and what's the expected parent name kind of thing. So we can so if someone tries to install malware on a machine and then just try and call it like system or SVC host or LSAS or something like this, so that it doesn't look odd when you look at the task manager, then we could pick it up, because we will say, oh, actually that's not right because it wasn't launched by the correct parent. So this is one of the attack techniques in the attack matrix. But this is just an example. So over here, I'm not going to go into it in too much detail, but that's the VQL that is being run, right? And then over here we have the parameters. So if I wanted to add another such relationship to check for, then I just add another entry in this list, and off we go, right? I don't really need to understand the query, but you can. I'm not going to go into it in too much detail, but people always ask us what's the difference then between VQL and OS query, or Velociraptor and OS query. And on the left, this is the same query from a project to map the attack framework for OS query, and so it's in SQL. But each of those sections here is its own query, and you can see that this one just looks for services.exe, so it's just one, right? So each line here, is like a paragraph of queries, and if you look at that query, it's actually really complicated. It's got a join, and it's actually really quite a complex query, and you have to copy and paste it for each one of those. So I'm not saying that, so that's fine, right? But it's just that the reason that we can work in a much more concise way is because VQL is so much more powerful, because we can pass parameters, and we have plugins that parse CSV files, so we can give the parameters of CSV files and so on. So let's have a look at how we can extend that idea. So this particular artifact is looking for event logs. So this is a triage artifact, which is just collecting files. And you might run it in order to say, well, give me all the event logs on this machine. I want to investigate them, as a forensic investigation. And we can do the same thing. We just basically give the possible locations for where the event logs might be in a kind of CSV file, so that the user can say, oh, there's another location you guys forgot about, let's add that in. It's very easy. You don't really need to understand VQL to add that in, and off you go. So I hope I kind of piqued your interest here with the power that having a very powerful query language gives you as a user. I'm just going to do a bit of a segue here to just show you how to set it up. And you might think, oh, it's kind of complicated to set up, but I'll just show you exactly all the steps that are required to set up a Velociraptor instance. So the first thing you need to do is create some configuration files, and you just ask Velociraptor to create a configuration for you. And this will generate keys and basically generate your initial configuration for you. So it asks us a couple of questions here. We answer the questions, and it basically builds a client config and a server config. And that's really all there is to it. They're just YAML files. The server config is for the server, client config is for the client. It contains all the key material that you generated for the authentication and cryptography. No, it's not blockchain. It's just normal. All right, and then to start the server, we basically just say it's the same binary again. We just give it another command. We say just the front end, start it up, and off we go. We can log into the UI, and same with the client. So the client, we have an MSI that we can ship, that you can deploy, and then you just drop the client config file, or you can just run it interactively like this. And this is kind of what it looks like. That's the dashboard on the front. We can see number of machines connected. This is a very small deployment, but you typically see this kind of wave, when people go home and come back, and so the number of clients just typically grows over the day, goes up, goes down, that sort of thing. So I just wanted to talk about the first instance. So let's say that you had Velociraptor in the first instance deployed everywhere, and then you wanted to investigate a particular machine. So you would say, well, okay, let's the first thing I would want to do is go and navigate the file system of that machine and just look at the user's files. So we have a virtual file system view in the GUI that you can just go and essentially interactively browse the endpoints, right? And so you can see over here we've got several headers like file, NTFS, registry, and artifacts. So these are the different things about the endpoint that we can parse. We can do NTFS, so raw NTFS access. We can use that to bypass any file locking, things like that. So let's say that we try to copy the user's nt-user.dat hive, which is where the user settings are. So typically, if a user gets compromised, the malware might actually insert itself into the user dat, into the user's part of the registry, not the system part of the registry. And so we'll need to go, we might want to go and copy that out, right? So we might go and navigate that, and it's normally stored in C users/username /ntuser.dat. But how do you know that? I know that, but you know, you just need to know, right? But then if you actually try to fetch it, you'll see that you can't actually do that because that file's locked when the user's logged in. So when the user's logged in, Windows locks the file, so you can't just copy it out. So now you actually need to access the raw NTFS bypass file locking and actually grab the file from the file system. So you need to know that for that file, typically, you would need to use the NTFS driver. And you can see here that we're using raw NTFS with C column and users nick and user.dat. So this is how you would, and you can see that you can fetch that file. When you download it, you see this little icon that tells you that you fetch that file and you can then grab it from the server. But you sort of need to know what you're looking for and exactly how to get it. And this is this kind of like example of specialized DFIR forensic sort of knowledge to do that. And what we try to do, and this is how you just basically can click download to get the file. So this is great, but it's very manual. It takes a while, and then you also need to know what you're doing. And we wanted to just basically solve that for everyone, right? Because we don't believe that people should need to. We want to commoditize this kind of forensic knowledge, right? So we created an artifact, and an artifact basically encapsulates that knowledge of where you would expect to find ntuser.dat and how you would expect to grab it, to be able to download it, so that you can see here it already encodes the fact that we have to use the NTFS driver to the NTFS access to grab it, and the location of where we expect it to be for each user, and it automatically grabs the ntuser.dat from all the users, right? Not just from that one. And so this is basically the next level of automation. And this gives you an idea of how you can use VQL to try and kind of encapsulate that knowledge, right? Because now all the user has to say is, oh yes, I just want to grab my end-user upload, just upload ntuser.dat, and it would just fetch it. So they don't need to really think about where they're going to get it from. That's what the VQL looks like. And then, imagine what happens next is that you find that a user was compromised on the domain, and then the bad guys use that compromised account to laterally move. That often happens across the domain, right? And so you want to know which machine did this particular user, log into, right? And so you might want to be more specific more surgical about getting the end users of just a compromised account. So what you would do is you would take that upload artifact and then customize it and just add a simple condition where the name matches. So that's the regex match operator, backup user account. So that's enough. Now you've just taken the artifact and changed it to be more surgical, more specific for your needs. So you don't really need to understand VQL at a deep level to be able to just tweak things a little bit and then just get the right artifact. So that's kind of level up. So we've seen that we could now encode this kind of idea. We've got an artifact, we've written the artifact, we've changed it to suit us. Now what we actually want to do is just run it everywhere. Before we saw how we could just collect from one machine, but actually we want to level it up. We want to just go grab it from all the machines at once. And in the Velociraptor terminology, we call this a hunt, right? So a hunt is basically where you automatically run the same artifact collection across the entire network at the same time. So you basically just go to the UI and you hunt, select the artifacts, and then just run it. So the hunt is basically something that's always running, and if a new machine joins, then it hasn't run the hunt yet, then it will pick it up and collect it. So over time, you'll get more and more and more machines joining. And so if you run the hunt for, say, a week, then you get a pretty good coverage of most of the machines that have been online, at least a little bit during that week. Yeah, so you can just select different ones. So you might, in this case, we might just grab the end user, evidence of execution, or all the Internet Explorer cache, for example, like all at once. All right, so we can do that. Now imagine that someone tells you, oh, there is this new malware, and it's actually kind of a bad one, and this is maybe a threat feed. Might say, well, you might find that the malware leaves its configuration file in a certain location. Maybe it's in the users /star. It might have a couple of dots, and it might have some random letters, and these kind of things. So you might say, well, I could look for that kind of file on all the machines and see maybe that would be the evidence that this malware is running. And so this is where we might use a file finder. A file finder is kind of a more generic artifact that is kind of very powerful. And you can see that it has a number of different options here. We can search for particular globs. We can search for keywords. We can use raw DFS, and we can limit it by, recent times, modification times. And over here we have this ops per second setting that actually requests that the endpoint lowers the rate. It's a rate limiting kind of thing, so it doesn't kind of hammer the endpoint with, trying to search for this file. It kind of goes low and slow, right, trying to find it, so it minimizes impact on the endpoint. So with this is kind of a Swiss Army knife of file finding, and you can actually achieve quite a lot. But all of it is written in VQL as well, so you can just modify it as well. But you can run that hunt everywhere and see which machines have been infected. Another example of such a thing is a hunt for sysinternal tools. So for example, like you guys all know that sysinternal tools are great. You can use them and they're really super useful. A lot of admins use them, but also hackers love to use them as well because we have psexec, we have handles, we have secure deletes. We have a lot of tools which are very useful for hackers. So what you'd like to do is find evidence that these tools have been run on a machine, and then that helps you to hunt for unexpected tools like that. So of course, sysinternal Microsoft, they already know that these tools are used by hackers, so they have left a special kind of artifact for us to find called the EULA. So when you run the sysinternal tool, you have to accept the EULA, and it leaves a registry entry for that, right? And a lot of the time the hackers forget to clean that up, so you can basically search for that, and that tells you, because of the timestamp of the registry key, then you know when it was created. So we have an artifact to just find that. So again, the artifact is similar. It's just a registry finding globe. It just finds we know the location of the registry key, and we just get the timestamp and present it in this way. And so we know, like, okay, psexec and sdelete were run, by the user Nick on this date. So if this was like an admin person, like not a system admin, but like an office admin or a accountant or something like that, that would be very strange. They probably don't really have a reason to run psexec. But if it's a sysadmin, maybe it's not so useful. So we have the Sans DFIR poster has a lot of examples of basically these artifacts that you can look for to find evidence of. So this is kind of the forensic artifacts, and there's a big list of them. User assist, shim cache, and so on. And what we try and do is write artifacts, Velociraptor artifacts, to try and basically automate all of these things, right? So we don't have to know where to look necessarily, but we can then present them all in the same artifact. So for example, in this more or less higher level artifact, evidence of execution, then we actually do all these things. We get the user assist stuff, we get the timeline, we get the recent apps, all these different ones automatically. So all the user has to do is click that one and get all the other ones. This is an example of what that might look like. There's the user assist hive, and we can see when it was executed, and the particular execution, the thing that was executed. So if we're looking for a malware, when was it executed, where was it executed from, this is the kind of evidence we can look for. The same thing for lateral movement, for WMIC, invoke WMI methods, all these kind of techniques that hackers love to use. All right, so we can also do the same thing for specific IOCs. So for instance, if we get a threat intel to say, there's a particular APT and they use a particular threat, a particular technique, and these are the artifacts that they might leave behind, then same thing, we could write a Velociraptor artifact to find those things and then do a hunt across the network and see if any of our machines have been owned. So this is actually super powerful because you can essentially respond. A lot of the time, it's like a whack-a-mole. If you find that one machine was compromised, then the question is, okay, I know that they use this kind of tool or this kind of technique on that machine. Where else have they been? And being able to hunt for it across all the machines at once means that basically you can find all the other lateral movement and how that group has moved through it. Hunt for shadow IT. So this one is actually kind of interesting. In this case, we might hunt for Dropbox usage. Who's using Dropbox in our company? But there's a bunch of different ways. That they might use Dropbox over the web. They might use the application. They might have a Chrome extension, and so you can basically use all of these generic artifacts, Chrome history, Chrome extensions, to basically look for specific evidence that people have actually used Dropbox. So if in history, if you see Dropbox website being accessed, or if they have cookies, that means that they've logged into Dropbox at some point, or if they actually have the Dropbox application installed, you can tell also when it was installed. So this could be useful for even just checking out to see that people are complying with policy and that kind of thing. All right, so we so far we were able to hunt everywhere and find evidence of bad stuff, right? But it's very reactive, like we suspect that something bad has happened and we have to go back and try and find that evidence. But what about if we change that and turn it into a way to be alerted when something bad happens? So we turn it into monitoring. Instead of just going to look for the badness, let's have Velociraptor tell us when something bad happens. And this is the idea of turning hunting into monitoring. And before we can talk about monitoring, I just wanted to talk a little bit about event queries and event artifacts. And so before I showed you how a VQL query basically returns rows and columns. And you might think of it as just sort of like a database query. You might say, it's just like querying a database. And if you ever query the database, you write your query, and the table comes back, and there you go, right? And in many ways, that's the case. But Velociraptor queries are asynchronous. It's not really a database. You're basically querying the endpoint, and you're running code on the endpoint. So the query doesn't actually have to terminate. So imagine if you were running a query that never terminates. So imagine it's a really slow database, right? So instead of just waiting there forever, watching the thing spin and not giving you results, imagine that it can just give you results one row at a time kind of thing, right? This is kind of what VQL is like. It's asynchronous. So if you have a query that never terminates, and let's say the query is just sitting there watching for particular events to occur, then as those events occur, the query will return one row at a time, stream into the server. And so that basically becomes a monitoring framework, because the query itself can just inform you whenever an interesting event happens, and then you can process that event in the rest of the query. So this is really what event artifacts are all about. And so they are actually streamed from the endpoint. And we have a buffer file on disk, so they're actually streamed even when the machine's offline. They're actually collected locally and then pushed out to the server. And then we can actually operate on those, and the query kind of runs on its own, right? Just sending us rows as it goes along. So this is called an event query. And what can we do with an event query? It's kind of interesting. Let's have a look. So an example is to monitor DNS on the endpoints. The DNS lookups are actually a really good indicator for malware, right? Because if you have information, like threat information about bad CNC domains, and you can go back through your DNS logs and see whether any of your machines have hit those bad DNS CNCs. You can use DNS logs to look for patterns, for repeating queries, for periodic queries. It's quite useful. You can log DNS on network hubs, but then you won't see any of your endpoints that are not on the network. If people are working from home or from Starbucks, you won't see that if you're only logging DNS on the network. So you're better off to log DNS on the endpoint and then have the endpoint push those events to the server, so you get better visibility, right? So Velociraptor can monitor the DNS, and you can essentially see that you can group it by a number of requests, and hopefully if it's a CNC, maybe you'll see a lot of requests, or you can look for whether the domains are like random and so on. The domain names are random and so on. But the interesting thing is that the DNS query is an event query, because essentially it's like running a query that never terminates. And every time the machine makes a DNS lookup, there's another row being returned and streamed to the server. So it just keeps going like that, right? So this is a type of essentially event monitoring. But let's level that up and do something a little bit more complicated. Let's look for monitoring USB devices. So a USB device is actually kind of an interesting threat from in many ways. People can plug them in and they can introduce malware, but also people can copy files from your file server, put them on a USB drive and go home, right? And then exfiltrate it that way. And so they can steal files, can steal documents and so on. And it might be against policy, but you need a way of knowing what's actually being copied to the thumb drive. Did they just plug their MP3 collection in and listen to it, or did they copy stuff to it, from the business documents? So just as an example, we can write an artifact that does that looks for thumb drives. And essentially what it does is it can look for the event of inserting a thumb drive, and then in this particular one, it just lists the directory, right? So it just gives you like a file listing of that thumb drive when it was inserted. And if any new files were added to it, so like the users copied files to it, it shows you those new files as just a listing of them. So you can use that to essentially just kind of keep across all USB activity, just logging it, right? And that query runs all the time on the endpoint. Even the machine is offline, it will just queue up the results and then flush them to the server later. But basically, you can see that this one query now allows us to do something that's kind of interesting, right? Like we just thought of it and wrote it in VQL, right? And that query can implement something useful. Now imagine that in this particular case we think, oh well, we don't really want to just see the listing. We're more interested to see whether that stealing documents are Office documents from like a confidential document. Maybe they're copying that to the thumb drive. So what that requires is we might want to see when a new file appears on that. If it's an Office file, I want to do a keyword scan of that and see whether it has the word confidential or secret or whatever your classification marking is. And so in order to do that, of course, you need to have a special kind of scanner, because most Office documents are compressed, and you have to actually scan the content, not just the zip file. But anyway, if you download Velociraptor and have a look, that's all implemented in VQL, that scanning, right? So in this case, but the interesting thing is that this artifact actually uses the previous artifact. So the the one from before, it simply lists all the documents, and this one scans it. And this is a similar one, just grabs the Office macros. I'm just worried about having macros on my thumb drive, and so it grabs the Office macros and uploads them to the server. And you can see how it uses the other artifact to list from the list, right? And then it restricts it by Office extensions, and then it grabs the OLE VBA files from that. So you can see that artifacts can sort of build on top of one another, and even event artifacts can build on one another and actually use each other. Okay, so now we want to level up again. So we can monitor stuff, we can get more information. What about doing something about it? What about responding? Well, it's actually not very much different than monitoring. We can turn monitoring into responding. Because the event artifacts on the endpoint are running all the time, then you can say, just as easily as I could have said to collect the VBA file, I could have said, well, if you find a VBA file, kill Word, or shut down, or send me an email, some kind of response, take action, right? But the interesting thing is that essentially that happens autonomously. So the endpoint already knows what it's doing. Instead of going to the server and then the server saying, oh, this is bad, do this, the endpoint already knows what the query is supposed to be doing. So it actually just sort of changes changes the game a little bit, because we now have a response plan. We have a plan. The endpoint knows what it's supposed to be doing, and it's autonomous. It just does it by itself. An example, block psexec, right? So psexec is, in some environments, maybe it's forbidden, maybe it's not allowed. So this particular artifact detects psexec by looking for a service installation from WMI, and then doing a Yara scan of the service, so to check if it's the psexec service, and then we use that artifact inside of this artifact to kill it, right? To task kill it. So you can build on that. So detection, the first artifact was about detection, and then the second artifact is about taking action, so response. And then there we go. There is actually a bit of a race condition here, because you detect it, then you kill it, so you might not kill it fast enough, right? But all right, so that's an example of events running on the client, on the endpoint. What about the server? We can also run event queries on the server, and when we run them on the server, it's the same thing as running on the client, but we can enrich the information on the server. So here's an example where we want to monitor for PowerShell, encoded PowerShell. And as you know, PowerShell has the option of giving it an encoded command. And it's actually really hard to see that. You see the encoded command, but it's hard to see past it when you look at process execution logs. You really need to sort of decode that. So what we actually want to have is some system to automatically decode that as it happens. So in this case, what we want to do is receive all the process execution logs as we normally do, but then if we see a process execution log that is a PowerShell with encoded command, then we want to just decode it. And here's what we would see from just the normal process creation, the process execution log that Velociraptor does, out of the box. That's what's sent from the client, from the endpoint. But if you see that, then that's not very helpful, right? Because you don't know if it's good or bad or anything. So we can write a short artifact on the server, and you can see what it does is it watches that other artifact. So it watches for all process execution logs, and then when the command line matches a certain encoded command, then it goes and decodes it. And so we might have. And it actually creates another artifact, another sort of table with just the decoded scripts, right? So you can see when something is bad straight away here, right? So this is a typical download Gradle from Metasploit or whatever. Okay, so that's cool. Now the last topic I wanted to mention is Velociraptor's automation possibilities. Because it is a very open platform. The whole point is to be very open. And so we actually have an API that you can use to write Python scripts and so on with Python or any other language to communicate with it. So I just wanted to give an example of how we would level that up through the API. How would we use Velociraptor inside our own script? So this is a scenario. What we want to do is look for certain binaries that are sensitive, for example, a service creation event. And we want to take those binaries, if someone created the service, and we want to upload them to a sandbox, like Joe Sandbox or Aristotle or something like that. So how do we actually implement something like that in Velociraptor? Well, here's the plan. This is what we're planning on doing. So the client is going to basically be sitting here, and then when a new service is installed, we're going to have an event log message written. It's a 7045 event log. The client is going to watch that event log for this message. When the message occurs, then the client, or the Velociraptor client, knows that a new service was installed, and then it can extract the binary, and then it will upload the binary to the server. Right? Then on the server, we're going to have a Python script that we're going to watch for those binaries being uploaded, and then in Python, upload it to the sandbox. So that's kind of the plan, right? So this is what we're going to use. This artifact on the client, Windows detection service upload, which essentially looks for a service creation event and just uploads the file. Then we're going to write some Python code here, and I'll just go through that. That's pretty much all the code there is. It's not very big. This is the function to upload to the sandbox, and you could do anything else with that file. You know, once it's been uploaded, you can archive it, take the hash, whatever. This particular, I think it's like 5-6 lines of code. That's all you need to connect to the API with Python. And then you can see that what we're doing is we are actually, all the API is, it's just issuing a VQL query. So it's just like connecting to the database and issuing a query. So we can issue this query, and I'll just go back one step. This query says watch for any new events, system upload completion. When an upload is completed, watch for that event, and then grab the file, and then for each reported one, we're going to print out these kind of information, and also call the submit file function up here, and then submit it. So that's really all there is. You can now set up essentially watchers that, you know, you can set up when if an event happens, you can push something to Splunk, or we can push something to Elastic, or we can do whatever. So that's how we integrate Velociraptor into other tools. You can also use that to issue other artifact collections. So you can say, you know, if something happens, then collect those other artifacts as well. So this is where we basically interface with external systems. So this is how it looks like in practice. The bad guy says sc create fake, and then the binary, right? And that immediately triggers the action, and it uploads that binary. And in our Python script, we grab the binary, we submit it to Joe Sandbox, and then a little while later, Joe Sandbox tells us malicious. Yeah, so that's our feedback there. So this is just an example of how you would use the API to integrate it into more of a complete pipeline. But I think the most interesting thing for me is this possibility for people to just kind of implement their own ideas, their own approaches by either implementing their own artifacts or implementing their own scripts around it using the API. Just being able to use it like a Swiss Army knife in different contexts and different ideas. So where to from here? So it is, first of all, I have to say again that Velociraptor is open source. Anyone can use it, and it's on GitHub. We have a development roadmap, you know, including this is some of those things we, you know, this is kind of what we thought about. But again, we really appreciate feedback from users to tell us what's important, you know, and what features people want. And we appreciate, you know, PRs as well, pull requests. There may be bugs. It's still kind of work in progress. But it's really exciting because I think what we're trying to do here is build a community and try and build a whole bunch of community shared artifacts and knowledge. Try and liberate that knowledge from people that have a specific forensic knowledge and then have that being accessible to everyone through different artifacts. So, yeah. So, please try it. Download the latest release. Read the manual. And send us an email and contribute back. So, thank you. Thanks.
Any questions for Mike?
Yeah, so you mentioned that communications between server and the client are encrypted.
Yeah.
Can you elaborate more on the authentication model between the client and the server? Because obviously, it seems like, considering that they're both the same binary and so on and so forth, the
Yep.
client itself can be used as a vendor effectively. So it's a target for the attacker itself.
So that's the same binary in the sense that it's the same code, but of course when a client runs as a client, as a service, it's being a client, right? It's not a peer-to-peer network if that's what you mean. So the communication protocol is encrypted over TLS, and then we have it's basically using the same encryption or authentication protocol as GRR, with it's elaborated in a lot of detail in the GRR documentation, but it's essentially a key-based, PKI-based system, right? To authenticate clients to servers, and then we have TLS on top of that again. So.
Thanks.
Yeah.
Thanks for the awesome presentation.
Oh, thank you.
And I have a question for the user experience. Is that possible to create some macros and instead of the writing the query, so the macro will expand it to the query?
When you say macro, what do you mean by macro?
Like for the query, for example, if I only want to provide the hash of the file, and make a query of whether this file existing at one host or several hosts. And then instead of writing the whole query statement, could I just using a macro and to abstract a lot of frequently used activities?
Yeah, that's a good idea. So let me just sorry. Actually, I think you can just jump to the right thing. So I guess this is what you are getting at here. So these parameter lists, right? For example, if you're in your case that you mentioned, like a hash list, and your query might say, does it match any of these hashes, right? But you don't want to hard code your hashes in the artifact because then you'd have to change your artifact all the time, when the hashes change, right? What you really want to do is to put your hash list maybe on the web somewhere, and then say go fetch that, and then compare it against today's hash list, right? That's what you're getting to, right? So that parameter, what you would do is the same technique, right? You put your hash list, which might be a CSV file or whatever, right? But in this case, you see how it's it's given as a parameter to the artifact, but you can actually host that, let's say, on a web page somewhere else. And then you can write your VQL artifact to say fetch that and parse it. And it's actually the same thing, right? If you look at you see what we have here, it parses the CSV file, and that's the lookup table, right, that it uses. So you can basically, instead of parsing it from a parameter, you can parse it from a web page that you get. So, and then when the artifact runs, it will fetch the CSV file, parse it, and then you can then just go ahead and manage that separately. That's what you're getting at, right? Like, yeah. So you can make it really complex, and in fact, we in this current release, which was done yesterday, there is ability to incorporate third-party binaries or files that are versioned, And it's exactly the same thing like you described. There's an inventory file with hashes, and then it just fetches like the latest one, and so you can push new versions of hashes or whatever it is that you want. Yeah.
You just mentioned the latest one. Is that possible to make a query based on the time range? Like only want make a query and for the last 3 days, for example.
So the query, so the VQL query doesn't query a database. There's no database, right? It actually runs. So this is the query, right? Select star from, and this is a plugin, which is a bit of code, right? And then if you wanted to limit that by time, you can go where time is greater than this or whatever, right? But yeah, so you can do, but it's not. It doesn't really have the data. It's not like a database where you can query over a range, except for the server where you're collecting the data. So yeah, you can do it on the server, but not on the endpoint. Is that what you mean?
Yeah.
Thanks.
Any other questions?
I'd just like to expand on what he asked. So for files, to be able to search them based on the file metadata,
Yep.
we'll be able to do that in DFIR?
Yeah, absolutely. So you can, so we actually have a full NTFS parser, so you can do things like search for the different attributes, and we're going to add more and more of the NTFS type forensic analysis, so you can detect things like time stomping and things like that. But as it is now, you can look for file metadata like timestamps and size and these kind of things, as well as you can run YARA SIGs on the content of the file, and then not only can you do that, but you can also do process memory and that kind of thing.
And another question, sorry. So is this, sorry, I missed the first 5 minutes of the presentation. Is this EXE actually running on the host itself?
Yeah, so it's an agent. Yeah. So the agent is running the client. We call it a client. It's running on the host, so it can be installed as an agent, so as a service. Or we also actually support an agentless mode where you can just push it with group policy and it just runs. And then you can just shut it down after a day or two, which is useful for doing a number of hunts in an incident response situation.
So in a traditional forensics perspective, you need to maintain the timestamp of all files. So when you're extracting the files, how are you maintaining the original timestamp of the files?
So are you saying that you don't want to change the access time when you access it? Right.
Yeah.
So if you do that, so there's a number of ways of accessing the files. Obviously, if you access them through the OS APIs, they might change access times. But we also have a raw NTFS parser that allows us to essentially do NTFS file system analysis on the endpoint directly, which doesn't really go through the normal file system, so it doesn't touch. It's a read-only, can't change any of the timestamps. Changing the access times. I mean that's a good point, but you have to be careful sometimes. But usually it's not that big a deal. On what we're trying to do here is sort of like triage an incident. It's not. So you can think about it, but it's not so critical in many cases to not change the system so much, right?
Yeah, I guess this is more for the incident responder rather than forensic practitioner.
It's for both, because I think the problem is that if you go around taking forensic images of everything, then it's just going to take a really long time. And if you have a big case with hundreds of machines, then you actually can't really do that in this way, right? So depending on the case, it may be acceptable to say, yes, it's been modified a little bit. We know how by us interacting with the live system. Yeah.
So will the code be able to admit those evidence when you presenting that, saying, hey, there's a possibility of changing the timestamp on these type of files?
Yeah, I mean, I'm not a lawyer, so I can't talk about code admissibility. But I mean, I think that as long as you know what's happening, it should be fine.
Thank you so much.
Any more questions?
More questions? Oh, there's one at the back there.
You mentioned that there was a slight delay between detect and respond. Can you elaborate a little bit on that?
Yeah. So basically, what's happening is we are not in line. Like we're not a kernel module that we have to consult before the process is allowed to continue. Right? We are simply monitoring it. So what happens is, if you look at, I'll just shift back to this particular case that it worked, the PS exec one. Yeah, this one. Right, so what's happening is that we are watching for the WMI event. You see there's a within one, which means the WMI is going to essentially check every second. So we have at least 1 second delay since the service was installed and we get notified, and then we actually go through and Yarrow scan it, so we can decide, like, there might be a second or two there. And so if you run so you see how in this command I ran psexec with sleep, so it will work. But if I run like a DIR, it's too fast, right? Because it just starts and stops. We don't actually get told about it quickly enough because we are not in line here in this case. So it's not like it's starting the service then waiting for us to tell if it's okay, like we're not really we're not in line. So there's a race condition here, right? So this is kind of the down part of not being in line. Is you can never actually stop something completely, But but this is an example of a response type activity.
Any other questions?
Oh, there's one there.
First off, great tool. I love it whenever we see automation that makes blue teams' lives easier. How are you planning, or have you had considerations around protecting the agent or having a server artifact that detects when it gets killed? Because one of the first things you do as an offense is this enumerate.
Yeah.
Cool. I need to work out how to deal with.
Yeah. So that's the never-ending problem. So at the moment it's installed as a system level agent, so service. So if you need to be system to stop it, or an admin to stop it. We don't really have any kernel module or anything like that we could, it's kind of an arms race, right? It is on the roadmap to do that sort of thing. At the moment, your best bet is to rename the binary. I mean, sometimes we do that. It's kind of lame, but because it's open source, you can sort of rebuild it, but it's not great. If you have any ideas of how we should do that, I would love to know.